10 seconds, that is roughly how long it takes to read this sentence out loud twice. Now imagine that in those 10 seconds, every molecule of oxygen gas in Earth's atmosphere simply vanished. Not oxygen in your body, not oxygen in water or rock, or the ground beneath your feet. Just the free, breathable oxygen gas floating in the air around you, the stuff making up about 80% of every breath you've ever taken. Gone for 10 seconds. Then back again. You've probably seen the viral version of this thought experiment before. Buildings crumbling into dust, the sky going pitch black, metal welding itself together on contact. Some of that is genuinely rooted in real physics. Most of it isn't, and by the end of this, you'll know exactly which parts to believe. So let's actually do this properly. Let's take the real chemistry, the real physiology, and the real physics of our atmosphere, and find out what 10 seconds without oxygen would actually do to a planet built entirely around having it. Because the true answer is stranger, and in some ways scarier, than the myth. It even turns out your own body has been secretly rehearsing for this exact scenario your entire life. Let's start by being precise about what we're actually removing, because this is where most versions of this thought experiment quietly go wrong. Oxygen atoms are everywhere. They make up roughly 2/3 of the mass of your own body, mostly locked inside water molecules in your cells. They make up nearly half the mass of the rock beneath your feet, bound into silicate minerals that have held the Earth's crust together for billions of years. If all of that oxygen vanished, chemically bonded oxygen included, you wouldn't get 10 seconds of chaos. You'd get the instant total unraveling of the periodic table's most common building block. And honestly, there'd be no after to talk about. So the version of this question worth actually answering isn't that one. It is the atmospheric version. Only the free, gas molecules floating loose in the air disappear, the ones plants release and your lungs pull in, while every oxygen atom already locked into water, rock, or your own cells stays exactly where it is. That is still an enormous planet-scale event. It is just one that leaves an after worth exploring. And the very first thing to break isn't your lungs or a flame or a building. It is the air pressure pressing on your eardrums right now. The first thing to understand is that removing 80% of the atmosphere is gas molecules isn't just a chemistry problem. It is a pressure problem. Air pressure exists because gas molecules are physically bouncing around and pushing on everything around them. Oxygen makes up roughly 1/5 of those molecules. So instantly deleting them means instantly deleting roughly 1/5 of atmospheric pressure everywhere on Earth all at once. That is not a gentle change. Picture ascending several thousand feet in an elevator in a single second. The kind of pressure slam that makes your ears pop hard on a plane. Except this time it is happening to every single person on the planet in the same instant. Eardrums, already delicate pressure sensors, would feel that shift immediately, and depending on how fast the change actually propagated, some people could experience genuine pain or minor injury from the sheer speed of it. Air would also physically move. Nature abhors an imbalance. And for those 10 seconds, wind patterns everywhere would shift as the remaining nitrogen-rich atmosphere adjusted to fill the new gap in pressure. Not hurricanes and force everywhere, but a real, measurable physical response. A planet's entire atmosphere flinching at once. And that is before a single flame engine or lungful of air even enters the picture. Because the moment that pressure wave settles, something else on Earth is about to go dark, all at the same instant. Every fire on Earth would go out immediately. Combustion is a chemical reaction that requires oxygen as the thing being combined with fuel. Remove the oxygen and the reaction simply cannot continue. Full stop, candles extinguish. Stovetop flames vanish. Wildfires mid-blaze would lose their fuel-oxygen reaction entirely for that window, even if the fuel itself is still sitting there, ready to reignite the instant oxygen returns. Internal combustion engines work on exactly the same principle, tiny controlled explosions of fuel and oxygen happening thousands of times a minute. Like a tiny lightning storm trapped inside a metal box, take away the oxygen for even a few seconds, and every gasoline engine on the planet would stall out mid-cycle. Cars stopping suddenly on highways, not catastrophic on their own, but multiplied across every road on Earth at the exact same instant, in the exact same 10 seconds. The one place this becomes genuinely dangerous is in the air. Jet engines depend on a continuous, uninterrupted flow of oxygen to keep burning fuel and generating thrust. This isn't purely hypothetical either. Pilots have lost all engine power mid-flight before, most famously when a jet flew through volcanic ash thick enough to choke its engines and had to restart them while falling through open sky. 10 seconds of flameout during cruising altitude is recoverable. Pilots train for engine relights. 10 seconds of flameout during takeoff or landing, when there is no altitude or time to spare, is a very different story. And in that same 10 seconds, something even stranger is happening, not in the sky, but inside every single person standing beneath it. Now let's talk about something almost every version of this thought experiment gets dramatically wrong. Your body wouldn't collapse the instant oxygen disappeared. Here is the part that actually surprised physiologists studying this scenario. 10 seconds is suspiciously close to a real measurable threshold the human body already has. When someone goes into sudden cardiac arrest and blood completely stops carrying oxygen to the brain, people typically lose consciousness in somewhere around 10 to 20 seconds. Wait, what? Your brain has a built-in countdown clock for exactly this kind of emergency, and it has been quietly running in the background since before you were born. That is not because the brain runs out of oxygen instantly. Your blood is already carrying a working supply when the 10 seconds begins, and your brain, despite being roughly 2% of your body's mass, burns through about 20% of your oxygen use just idling. So for those 10 seconds, you wouldn't suffocate. You'd start burning through the oxygen already in your bloodstream, the reserve you are carrying right now, this very moment, without knowing it. Most healthy people would feel a wave of lightheadedness, maybe some visual dimming at the edges, the same sensation fighter pilots call the onset of G-low-C gravity, induced loss of consciousness right before blacking out. Unknown already low on reserve, people at high altitude, people mid-exertion, people already on supplemental oxygen would be pushed far closer to the edge. And for some, 10 seconds might be exactly long enough to tip over it. For most of us, though, the 10 seconds would end just before the real danger began. A genuinely unsettling amount of a coincidence, not a design. But while your body is quietly running that emergency countdown, something is happening over your head that most people would completely miss. Let's go back outside, because the sky itself would look subtly different, just not the way the internet thinks it would. The popular version of this thought experiment claims the sky would instantly turn black. That is not quite right. The sky is blue because of Rayleigh scattering, sunlight bouncing off gas molecules in the atmosphere, preferentially scattering shorter blue wavelengths in every direction. Nitrogen makes up about 78% of our atmosphere, oxygen about 21%, and both contribute to that scattering effect, just in different proportions based on their different molecular properties. Remove the oxygen, and you remove roughly a fifth of the atmosphere is total scattering molecules. But nitrogen alone is still there, still scattering light, still producing a blue sky, just very slightly dimmer and very slightly shifted in exact hue. Less like flipping a switch, more like nudging a filter one notch to the left. Not blackout, not even close. A change so subtle, most people staring straight up wouldn't consciously register it at all in 10 seconds. The much bigger myth to debunk involves the ozone layer. Many versions of this scenario claim instant, deadly UV exposure the moment oxygen disappears. But the ozone layer, made of OFE molecules, sits in the stratosphere as an already jan-formed reservoir, built up over the ozone-jan-oxygen cycle across long timescales. Removing fresh oxygen at ground level for 10 seconds doesn't unjan-form ozone molecules that already exist miles above your head. The shield stays up. The sun doesn't suddenly turn deadly, so the sky survives the myth intact. The ground, on the other hand, is where the internet's favorite claim is about to completely fall apart. There is a myth about the ground itself worth addressing directly, because it is the most viral claim of all that concrete buildings would crumble and the earth would give way. This claim usually comes from confusing atmospheric oxygen with the oxygen chemically bonded inside minerals, cement, and rock, which, as we established earlier, isn't part of this scenario at all. Concrete's strength comes from calcium compounds that already contain their oxygen atoms locked in place, chemically, structurally, permanently, completely separate from the oxygen gas floating in the air around it. Remove atmospheric, all for 10 seconds. And concrete doesn't even notice, neither does the rock beneath your city. The other viral claim that exposed metal surfaces would instantly weld themselves together does have a kernel of real physics in it called cold welding, but it needs conditions this scenario doesn't actually provide. Cold welding happens in a genuine vacuum in space, where perfectly clean metal surfaces with literally nothing between them. No oxide layer, no adsorbed gas, no moisture touch and fuse at the atomic level. It is actually a real problem engineers have to design around on satellites. Removing only the oxygen from Earth's atmosphere still leaves nitrogen, water vapor, and other gas molecules coating every surface, which is more than enough to prevent that kind of instant atomic bonding. Your car door wouldn't weld itself shut in those 10 seconds. The myth borrows real orbital mechanics and physics, then smuggles it somewhere it was never meant to apply. And if buildings, cars, and the sky are all quietly fine, you'd expect the ocean 3 quarters of this planet's surface to be in absolute chaos. It is about to do the opposite. Underwater, something genuinely interesting and genuinely underappreciated would happen almost nothing, at least not immediately. Fish don't breathe atmospheric oxygen directly. Their gills extract dissolved oxygen already present in the water itself, a separate chemical reservoir from the free or gas floating above the surface. For those 10 seconds, the dissolved oxygen already in rivers, lakes, and oceans wouldn't vanish along with the atmospheric supply, because it is a different population of oxygen molecules, already dissolved, already available. Aquatic life would continue, almost entirely undisturbed, while the drama unfolded in the air above them. The one exception, the paper-thin surface layer of water constantly exchanging gas with the atmosphere, would briefly lose its usual replenishment source, a genuinely tiny effect over 10 seconds, invisible to virtually every fish in every ocean on Earth. It is a strange detail to sit with. In a scenario this catastrophic sounding, an entire kingdom of life would barely register that anything happened at all. But up on land, the 10 seconds are about to end, and the moment oxygen rushes back in might actually be more dangerous than the moment it left. So what happens the instant those 10 seconds end and oxygen rushes back? This is where the story gets its most physically dramatic beat, because nature doesn't like an imbalance any more on the way back in than it did on the way out. Air pressure would snap back toward normal, and depending on how the oxygen actually returned, that could mean another rapid pressure shift, another jolt for ears and lungs already stressed by the first one. Every stalled engine, every extinguished flame sitting next to leaking fuel or gas would suddenly have its oxidizer back. All at once, everywhere, simultaneously. Which is exactly the moment the return of oxygen could become more dangerous than its disappearance ever was. Fires that had merely gone out, rather than fully cooled, could reignite explosively the instant oxygen returned, especially anywhere heat, fuel, and freshly restored oxygen met again in the same fraction of a second. For the people who'd started to feel lightheaded, or who'd begun losing consciousness right at the edge of that 10-second window, the returning oxygen wouldn't undo the danger instantly either. The brain, once oxygen-starved even briefly, needs real time to recover, not just an instant restoration of supply. The 10 seconds would be over. The consequences of those 10 seconds for engines, for aircraft, for anyone already at the edge of consciousness would still be unfolding step back. And the real answer to this question turns out to be more interesting than the viral version, not less. The dramatic myths, crumbling buildings, welded metal, a black and starless sky, mostly come from quietly swapping in the wrong kind of oxygen partway through the thought experiment. The real physics is stranger in a quieter way, a planet's entire atmosphere flinching in a fraction of a second, every flame and engine stalling in perfect unison, an entire ocean of fish not noticing anything happened at all. And human consciousness sitting right on the exact edge of a 10-second threshold, your own bloodstream is quietly defending. Right now, without you ever having to think about it. We don't usually think of oxygen as something being actively, continuously fought for. We just breathe it, the same reflex, thousands of times a day, without a second thought. But somewhere underneath that reflex is a body running an emergency reserve system precisely tuned to a window of about 10 seconds. The exact length of time this entire thought experiment asks you to imagine losing. That is not a coincidence built for this video. It is a coincidence built by evolution long before anyone thought to ask the question at all.